The study of the universe spans almost inconceivable extremes of size and distance and time. From the vast island of stars we call a galaxy, to the tiny atom and the particles that comprise it. From cosmic events that occurred billions of years in the past, to microcosmic events in the present that endure for only billionths of a second. To explore the universe at these extremes, the scientist builds instruments that extend his reach and his vision. His great telescopic eye has the light-gathering power of 1,000,000 human eyes. It peers not only into the depths of space, but far back in time, since the light it now observes may have left its source when dinosaurs inhabited the Earth. His telescopic ear is tuned to the invisible radio sky. It detects not objects, but the radio regions associated with them, and at distances far beyond the range of the largest optical telescope. But the radio waves and the visible light that pass through the Earth's atmosphere to these ground-based telescopes are only part of a broad spectrum of radiation, most of which is blocked by the atmosphere. So electronic instruments are lifted above this murky and turbulent layer, airborne by rockets, by balloons, in unmanned astronomical observatories, in manned laboratories, and in spacecraft orbiting the planets. Instruments probe the near and distant environments of space and open new windows on the universe. In the beginning, it is believed, all the matter of the universe was contained in a primordial atom, an unimaginable concentration of elementary particles. In one gigantic detonation, the contents of this cosmic fireball were hurled outward in all directions. After 1,000,000 years of expansion, the universe was an intense blaze of light. Then the radiation cooled, and after hundreds of millions of years, great clouds of hydrogen gas began contracting, and in time, evolved into the galaxies we now observe. Inside these galactic whirlpools, smaller fields of gravity condense hydrogen into stars. Stars are inconceivably hot. So hot, they sustain thermonuclear reactions that transform hydrogen into heavier elements. Sometimes their hydrogen fuel burns so fast, they flare out in violent explosions, hurling new elements across space. Like a great wind, the radiant energy of starlight drives these clouds of dust and gas throughout the galaxy. Out of these clouds evolve new generations of stars. More than half the stars in our galaxy travel in groups of 2 or more, orbiting around a common center of gravity. Like galactic comets, Immense clusters of stars swing in and out of the galaxy in vast, eccentric paths. Some small stars do not travel in the company of other stars. Our own sun is one of these. To the astronomer, the sun is a vast laboratory for the detailed study of a star's structure and energy. The vertical tower of the solar observatory supports a heliostat mirror which tracks the sun, gathers its rays, and reflects them down a light shaft that extends 300 feet below ground. At the end of the shaft, the rays are cast back to an observing room where minute-by-minute changes across the face of the sun are observed. Another mirror projects a light beam to a spectroscope, an instrument which splits the light into its component colors, a visible spectrum. The dark lines that cut across the spectrum band are produced by the radiation from the sun's interior shining through its atmosphere. Each line is the signature of a chemical element such as sodium, iron, calcium. It is this array of lines that forms the code which describes the properties and motion of a star. By narrowing the view of the sun to a single line of the spectrum, each level of the solar atmosphere can be photographed, and each reveals a remarkably different aspect. And with the addition of computer mapping and color processing that distinguishes levels of brightness, a detailed and multidimensional picture is obtained of a sun undergoing dramatic and turbulent change. The sun is a sphere of hot, seething gases and surges of radiation. Most of the light we get from the sun comes from the thin, bright layer which defines its visible edge, the photosphere. Above it, the chromosphere, a region of flaming outbursts of gas, extends through a transition zone to the thin outer atmosphere of the corona. Once thought to be a quiet layer of the solar atmosphere, the corona is now revealed to be a region of dramatic large-scale changes and unexpected turbulence, with temperatures reaching millions of degrees. Deep beneath the sun's atmospheric shell is the core, a violent nuclear furnace. Here, hydrogen is fused into helium, and in the process, some of the matter is converted into an enormous amount of energy. Radiating outward as a gas, it convects like a boiling liquid beneath the surface. The turbulent, bubbling motion is visible in the granular cells of the photosphere. Sunspots, regions of intense magnetic fields, appear on the surface, disappear in a few hours, or grow and persist for months in a mysterious 11-year cycle. The sun rotates once in 27 days. Because its equatorial regions rotate faster than the polar caps, the shearing action in the gas contorts the magnetic field into tangled structures which give rise to the sun's eruptive action. Shaped by these magnetic fields are the spectacular prominences, titanic streamers of gas reaching heights of more than 500,000 miles above the surface. The greatest explosions in the solar system are flares, intense bursts of light erupting with the force of billions of hydrogen bombs. They move at hundreds of miles a second. Then, after minutes or hours, they fade away. The dark areas across the solar disk are coronal holes, which may provide new clues to the sun's interior, and may be a source of the solar wind that blows outward to the farthest planets. On Earth, the effects of these solar events are visible when auroras light up the dark Arctic sky and radio communication is disrupted. The Sun is an average, middle-aged star. Yet it will generate heat and light for billions of years to come, as it has for 5 billion years past. It dominates the motions of all bodies in the solar system. Nearest the Sun and obscured by its intense glare is Mercury, a cratered planet much like our Moon. Temperatures rise to 800 degrees, but no clouds or atmosphere protect its ancient surface from the searing heat. Moving outward from Mercury, we encounter Venus. Its perpetual cloud cover traps the radiant energy of the Sun within an atmosphere of incredible pressures. From the surface, only a reddish glow reveals the presence of the Sun. Beyond Venus, 93 million miles from the Sun, is Earth. Its great oceans forming the clouds and air currents which warm and irrigate the planet, shape its continents, and nourish life. Its satellite, the Moon, airless, waterless, and scarred by meteors that have bombarded it since the time of its formation, now bears the imprints of our astronauts. A probe of the planet Mars has discovered a dynamic and evolving planet with unexpected geological features. A volcanic mountain, many times larger than the largest volcano on Earth. A vast and deep canyon extending for 2,500 miles. And dry, river-like channels that may have been carved by running water. Beyond the orbit of Mars is the belt of asteroids, craggy chunks of rock and metal, some as small as boulders, others hundreds of miles in diameter. About 500 million miles from the Sun, we encounter the first of the giant gas planets, Jupiter, the colossus of the solar system, more massive than all the other planets combined. Deep beneath the maelstrom of clouds that band its surface is a primordial atmosphere much like that in which life awakened on Earth millions of years ago. And drifting on its surface is the mysterious red spot, an immense cyclonic storm that has raged for hundreds of years and continues unabated. Radiating more energy than it receives from the Sun, and circled by 14 moons, Jupiter is like a miniature solar system. The next largest of the gas planets is Saturn, girded by rings which, as we approach them, resolve into countless particles of frozen debris and ice, each a tiny moon orbiting the massive planet. And as we continue past the frozen worlds of Uranus and Neptune, we arrive at the outermost planet in the solar system, Pluto. It moves in a dim twilight of unimaginable cold. The Sun, 4 billion miles away, has only a brilliant light in the night sky.
You're watching Sleepcore. Pleasant dreams.
For thousands of years, people have wondered, are we alone? If the answer is no, then we look forward to one of the most exciting events in the history of the human race.
The idea of extraterrestrial life really got rolling at the end of the 19th century when Percival Lowell started popularizing Schiaparelli's discovery of the so-called canals on Mars. These were seemingly an indication that there was intelligent life on the planet, and so a series of relatively imaginative ideas for communicating with those Martians were proposed, including one notion to light gigantic forest fires across the face of the Earth to spell out our message like some gigantic halftime card stunt, and presumably the message would be, "Help, fire." Well, people took the idea of life on Mars so much for granted that at the end of the 19th century, a wealthy Frenchwoman, Madame Clara Gauguet, offered a trunk full of money, a prize of 100,000 gold francs, to the person who first succeeded in establishing communication with beings on some other planet. With the one exception of Mars, she said, that would be too easy.
Whenever you're talking about extraterrestrial life or intelligence, since there's no unambiguous evidence that we've detected anybody or seen anything, the whole question is based on a lot of assumptions. And one of the assumptions, or the biggest assumption, is the so-called assumption of mediocrity, which says that since the circumstances of our existence here on Earth seem to be very ordinary, the Earth is a very ordinary planet, the sun seems to be an ordinary sun stuck in the middle of a quite inconspicuous galaxy, and so on and so forth, there doesn't seem to be anything special about us, and therefore we have to assume that there are other places which by and large are very much like the Earth in the universe, and that there are many of them, because we know that there are 100 billion stars in our galaxy alone, and there are at least that many galaxies in the universe, and therefore why should we be the only ones?
So every time people have thought that there was something particularly special or unique about the Earth, so far it's turned out to be wrong, and therefore the optimists feel that if we argue that way in regard to life, that we're the only life in the galaxy of the universe, then that's anti-Copernican and therefore isn't a good way to look at things. So, you know, that's an argument. I don't personally find it very compelling, but it's not an unreasonable argument, and so the idea is that really one should go out and look for these technological civilizations.
Astronomers now speculate that as many as half the billions upon billions of stars in the universe have planets. But the mere existence of a planet does not necessitate the existence of life. Scientists believe that there's a range of distances from a star called the life zone in which life is more likely to form. This is the distance at which water is a liquid. Too close to the star, it would vaporize, and too far away, it would permanently freeze. While water is not essential to all forms of life, it's a nearly universal solvent which would help speed up the random chemical reactions believed necessary for the formation of life. 3 planets are technically within the life zone of our sun: Venus, the Earth, and Mars. Neither Venus nor Mars seems to have liquid water at the present time, but if the Earth were moved to either of their orbits, both the oceans and life would still survive on our planet. So other factors besides amount of solar radiation have hindered the formation of life on these nearby planets. Mars, 1/2 the size of the Earth and half again as far from the Sun, presently has only a thin atmosphere. Its atmospheric pressure is too low to keep water in a liquid state. Water on the red planet remains as a vapor or as ice. Venus is nearly the same size as the Earth, but it's closer to the Sun. Based on the amount of solar radiation it receives, temperatures on the planet should be about 150 degrees Fahrenheit. However, a runaway greenhouse effect caused by excessive carbon dioxide in the atmosphere keeps the planet's temperature at a hellish 900 degrees Fahrenheit. Earth's temperatures are certainly more moderate, although it had a similar origin to Venus. Soon after the Earth formed, volcanoes began to spew out gases from the interior. Much of the water vapor produced by the volcanoes condensed into clouds. Rain fell on the planet, creating the oceans. In 1924, the Russian biochemist Alessandro Oparin speculated that life could have originated from organic compounds in the primitive oceans. This theory was tested by Stanley Miller in 1953, when he conducted an experiment designed by Harold Urey at the University of Chicago. In a flask, Miller mixed methane, ammonia, water, and hydrogen, gases contained in the primordial atmosphere. This mixture was circulated past an electrical discharge, simulating lightning. When the products of the experiment were analyzed, an exciting discovery was made. They were found to contain 4 amino acids, structural units of proteins found in all living things. Miller's work showed that the gases of the primitive atmosphere, exposed to an energy source, could have combined to form simple organic or carbon-based compounds, similar to those found in living things. Astronomers and biochemists think that these same conditions exist or have existed on planets throughout the universe. If these elements have combined to create life on planets in other parts of our galaxy and the rest of the universe, what form might these beings have? Can we, in even our wildest flights of fantasy, ever come close to imagining what other life forms might look like? Forms of life on Earth alone are enormously varied and complex, and yet all these forms evolved from the same ancestors on the same planet. If all life except the simplest one-celled creatures were destroyed on Earth, and life was allowed to evolve all over again, it would probably not evolve into humanoids. There is such a variety of totally random paths that evolution could follow that it is very unlikely that it would follow the same path again. Life on another planet could have an entirely different chemical basis from life on Earth. But even if it had the same chemical basis, evolutionary and environmental factors could cause it to be substantially different from life on Earth. Perhaps it would be almost unrecognizable as living.
People often think in terms of spacemen visiting the Earth when they come here. They always look like human beings, one form or another. They have big heads, or they have green heads, or they have big eyes, but they always have 2 eyes, and they always have a nose below their eyes, and they have a mouth, and they have two legs, sometimes a tail, but they tend to be humanoid looking, you see in science fiction. I think astrophysically there's no reason to believe that the humanoid morphology of advanced life is common. For example, if you triple or quadruple the gravity on the Earth, characteristic of a planet such as Jupiter, for example, which should be a common enough sort of planet, human beings of our form could not have evolved on a planet like that because the gravity is too large. We don't have the structural strength within the bones and the molecules in our body to support us, so that we'd most likely be a 4-legged or a 6-legged creature crawling around on its belly like an alligator, just because you're wasting too much energy standing up. Alternatively, if you formed on a light planet, it might be much easier to fly around. Even someone as massive as a human being could fly around quite easily on a low gravity, thick atmosphere planet. Furthermore, it may be that it's more advantageous biologically to evolve and grow in a liquid rather than in air. We don't know this. So it may be that when you look at all the life forms that there are in the universe, assuming that there are others, I think that 2 eyes, a nose, and a mouth is a very unlikely form, and a humanoid form is almost certainly unlikely.
Having made the assumption that other intelligent beings do exist in the universe, scientists would next like to estimate how many civilizations with communicative capabilities equal to or greater than our own exist. Dr. Frank Drake of Cornell University has created a formula for this estimation based on the average rate of star formation, the fraction of a galaxy's stars with planetary systems, the average number of planets in such a system with environments favorable for the origin of life, the number of planets on which life actually develops, the fraction of these inhabited planets in which an advanced technological civilization arises, and the average lifetime of a technical civilization. When all the calculations that can be reasonably determined by scientists are put into the formula reduces to one major unknown, the lifetime of a technical civilization. The number of extant technical civilizations possessing both the interest and the capability for interstellar communication depends on the average lifetime in years of a technical civilization. This number could be anything from millions within our galaxy alone to only one, us.
Shortly after Drake and his colleagues first explicitly wrote down this equation, they tried to put in their best estimates or guesses as to what these probabilities and lifetimes and whatnot are. And generally people like Drake and Carl Sagan and Phil Morrison are regarded as the optimists in the field, or have been for quite a while now. And they tend to choose values for these probabilities and lifetimes that many of us would regard as quite optimistically large, that is, because they seem to want there to be a lot of life in the galaxy. On the other hand, people such as my colleague Michael Hart and other people like myself aren't quite as pessimistic as Hart, but still believe the origin of life is quite an improbable event, would put a very small number in for this probability, a number not much bigger than 0. It's really just a guess as to how big this number is. And depending on whether you're Drake or Sagan or whether you're Michael Hart or something, you could come out with numbers that differ by factors of trillions in your estimate of what capital N is. In other words, when Drake and Sagan finally go through their calculations and estimate capital N, they come out, typically, if say 100,000 civilizations in our galaxy. And that means that if you've got 100 billion stars in the Milky Way, about one star in every million or so would have evolved a technological civilization on a planet around it. Whereas the pessimists, the extreme pessimists like Hart, would feel that the probability of, say, even the origin of life is so slight that you'd be lucky to find another technological civilization in the entire universe.
In 1976, Vikings 1 and 2 landed on Mars. They performed complex experiments to try and determine whether microorganisms similar to those found on Earth existed on the red planet. The results were ambiguous, leaving scientists to wonder whether unusual non-organic chemical reactions took place in the soil or whether there might actually be a very strange form of microscopic life on Mars. Scientists are anxious to send probes into the clouds of Jupiter and Saturn, which have warm internal temperatures and similar atmospheres to that on the primordial Earth. They also hope to orbit and perhaps land a spacecraft on Saturn's largest moon, Titan. This distant satellite is known to have water vapor and a substantial atmosphere. This atmosphere creates a greenhouse effect, possibly warming Titan to life zone temperatures. Already we've cast a message in a bottle into the cosmic seas. The two Pioneer spacecraft on mission to Jupiter and Saturn each carry a kind of postcard, a plaque depicting human beings and the Pioneer spacecraft's path and showing the location of Earth in the galaxy. These spacecraft, which will last for millions of years, will be the first human artifacts to escape the solar system. Traveling at a speed of 25,000 miles per hour, It will take these spacecraft about 25,000 years to travel the distance of 1 light year. The 2 Voyager spacecraft, also on their way to the outer planets and beyond the solar system, both carry records which contain pictures and sounds of Earth. Directions for decoding the cosmic records are written in the language of mathematics.
You're watching Sleepcore, media for insomnia.
Space. An endless tapestry of stars reaching toward infinity. Scattered through its vastness are 100 billion planets on which life theoretically could exist. If only 1% of that life is intelligent, there could be 1 million civilizations out there. And of that million, it is conceivable that one discovered the secrets of space travel. It is possible that ancient astronauts went in search of life beyond their own world and found it on the planet Earth. The existence of other intelligent beings in the universe intrigues the men of tomorrow's science, the exobiologists, students of life in outer space. Dr. Harold P. Klein of NASA's Ames Research Center.
The knowledge that this kind of life that we know of in this planet is not the only one will have very profound influence, whether that other life is more advanced or less advanced than we are. The very knowledge that life can originate spontaneously will have, I believe, very profound effects on the thinking of man in terms of what he is and what his role is in the universe.
Now, it has been suggested by other people that maybe life on Earth was brought here by a visitor from another planet.
Dr. James Lawless.
While this possibility is remote, it certainly can't be excluded on the basis of the results which we have found.
If ancient astronauts did land here, what effect would they have had upon early Earthmen? Perhaps they were worshipped, feared, loved. Perhaps they brought gifts, a new world of knowledge, or simply the principle of the lever. If we accept the premise that beings from another civilization visited here ages ago, then some of the mysteries of our past take on a new and startling light. The Baghdad Museum in Iraq has on display a clay vase dating back before the birth of Christ. The vase is also a 2,000-year-old battery. A small copper tube is placed in the narrow neck, and a rod made of a metal alloy is inserted in the copper tube. When filled with hydrochloric acid, it produces an electric current. The vase was, it seems, a primitive galvanic cell battery. Count Volta is credited with having invented the electric cell 2,500 years later. Was the secret of electricity revealed to man thousands of years ago? Is it possible that this planet Earth has been visited by travelers from outer space? Did they wander through the throbbing light years of the universe in search of other life and find it here? Is a storehouse, an archive of unexplained phenomena. Gigantic creations, in effigy of what? To appease or acclaim whom? Early stone carvers left silent records for their descendants, to tell us something, but not quite enough. Statues modeled after strange beings, statements to the scope of their awesome powers. Folk legend surrounds their origin. Strange stories of gods who appeared riding across the skies in flaming chariots of light. Whole civilizations were structured around these gods. Civilizations which at one time flourished and then mysteriously disappeared. Only stone relics survive to give mute testimony to their time. Their true history has been the cause of much scientific inquiry and romantic speculation. Erich von Däniken, a German professor possessed of the mind of a scientist and the imagination of a romantic, wrote a book called Chariots of the Gods. He stated that sometime in the distant past, man was visited by intelligent beings from outer space. What in olden times might have been heresy is today intriguing speculation. Von Däniken traveled to all corners of the world, gathering evidence in support of his theory. Or is it a theory? Judge for yourself. Istanbul, the city on the Golden Horn. Here stands the Palace of Topkapi. A curious set of maps are kept here, which were found in the Orient by the Turkish Admiral Piri Reis. The oldest of these maps dates back to approximately the 1st century A.D. They are most likely copies of still earlier maps. As astronauts high above Cairo, we would view the Earth in the configuration seen on the old maps. The outlines of the modern maps are the same as the pattern visible on the Piri Reis charts. Another map in the collection shows a region which is still largely unexplored, the Antarctic. The existence of Antarctica as a continent was only established in the 19th century, and it wasn't even explored until 1911 by a Norwegian, Roald Amundsen. The map dates from 1532, a time when the techniques and basic equipment were unavailable to determine longitude. The question lingers. What was the source of information? The world's first great cities might have been constructed, according to von Däniken, under the supervision of the same being who offered instruction for making the maps of Piri Reis. Teotihuacan lies on a broad, flat plain curtained by mountains in central Mexico. It was once the center of the highly advanced Aztec Empire. When the Spaniards arrived in the early 16th century, they found an established society of artisans and intellectuals. The name Teotihuacan means where the gods reside. And the city of the gods is dominated by the Pyramid of the Sun. It is 216 feet high and forms a small mountain weighing 2.5 million tons. The Aztecs worshipped the sun as the source of all life. They offered human sacrifices to the sun god atop stone pyramids marked with glyphics, vague symbols relating the history of an ancient people. Archaeology seeks answers to questions about man's past by digging through what he has left behind. Here they uncovered a chain of riddles which stretches across the expanse of modern Mexico. A mile to the south is the temple of Quetzalcoatl. Legend tells us that he was a light-skinned, bearded man who came from the stars. Supposedly, he taught men law, the arts, and the cultivation of corn. The head of a great feathered serpent represents the god Quetzalcoatl. When Quetzalcoatl finished his mission on Earth, he departed to his native star, promising to come back someday. It is a pervasive part of mythology that gods fly to the stars with a pledge to return. The strain runs through all folklore. The ruins of the deserted city of Tula rest about 20 miles from Teotihuacan. It was one of the cities supposedly linked in legend to a ladder hung in the sky. Monumental sculptures stand as silent watch over the remains, guardians of an eternal mystery. They appear to be warriors, dressed alike, wearing unusual helmets. They carry some sort of box-like unit on their chests. Perhaps they are weapons or communications equipment. Unrecognizable tools or controls are clasped in their hands. The nearby sacred well of Cenote forms a perfectly round crater in the rock. It is unlikely that it could have been formed naturally or by human excavation. It does, however, resemble a crater made by the exhaust gases of a very powerful rocket engine. To the east of Cenote is the ancient Mayan city of Chichen Itza. About 600 A.D., the entire Mayan population fled northward. There is no trace of war, plague, or famine to account for the move. Outstanding astronomers, Mayans calendared the year by constructing a central pyramid with 365 steps. They also developed a formula to predict eclipses without ever knowing about the revolution of the Earth, Moon, and Sun. There is no way of telling how they discovered these secrets, but von Daniken believes that some ancient astronaut may have told them of the solar system in which they lived. A stone relief portrays a god in a helmet with projections resembling antennae. The Mayans name their patron Kukulkan. In every 6,000 years, the Mayan calendar is off by only one day. Such was the gift of Kukulkan. Kukulkan supposedly came from the stars and returned to them, leaving the Mayans to build observatories to search the heavens for him. Perhaps with our modern observatories and telescopes, we are still searching for Kukulkan and Quetzalcoatl, who deserted to ancient skies. Modern science examines the heavens in search of information. Data, according to Dr. Werner von Braun, that gives us perspective on our own brief existence in the firmament.
I think it is important to remember that distant stars are not only far away from us in terms of miles, but life on other planets can also be very far away from us in terms of time. The Earth is believed to be approximately 5 billion years old, and if you condense mentally these 5 billion years into 1 year, then the presence of men on this Earth would be about 1 minute out of that 1 year, and the period since man understood radio and was capable of effectively communicating with heavenly bodies outside of the Earth would only be approximately 1 second out of that year. So if you want to communicate with another heavenly body and intelligent life thereon, you have to reach that other heavenly body also at a time when these people have invented the radio and know how to operate it and have their receivers going, so to speak.
But we had no receivers going, even a mere 50 years ago. We were too busy with the steam engine and the biplane. Dr. Harold Klein.
It is highly possible that advanced civilizations have in the past, or may in the present, try or have tried to contact us, to survey us, to watch us. We cannot rule that out. We have no indications of that. It may be equally possible that a really intelligent society has watched us for some time, has looked us over and decided, based on our activities, that this planet is beneath their dignity, so to speak, and is simply not worth bothering with.
Quite possibly we were too backward to bother with, but we have come a long way in a short time, and we are prepared to reach out into the universe. Writer and sociologist Eric Hoffer suggests a reason for our return to space. He wrote, "I always felt that man is a stranger on this planet, a total stranger. I always played with the fancy, maybe a contagion from outer space is the seed of man. Hence our prior occupation with heaven, with the sky, with the stars, the gods, somewhere out there in outer space. It is a kind of homing impulse. We are drawn to where we came from."